Now look at this question. It is quite different. Two sets is given to us and a relation is defined in such a way that R is a relation from A to B and it is defined as x plus y is even. These kind of problems will be in first PU, hope so you definitely not remember that. Just repeat once again. Defined by x plus y is even. So in this case relation is not directly defined to us, but they asked us to write the relation again and find the nature of a relation. So how can I write the relation as? Relation given is x plus y should be even. So we have to write the relation, ordered pair of a relation such that the elements in the ordered pair, when you're going to add, the element should be even. I'll give you one example. Suppose first element I am going to take 1, 1, 2. When you're going to add, suppose if I'm going to write 1, 2, 1 plus 2 should be even number. That is what the meaning is. But when you're going to add 1 plus 2, you will get 3. It is not even. So I cannot take 1, 2. Fine. But just you have to do randomly the cross check. 1 plus 4. 1 4 you are going to take, you will get 5. So it is not an even number. Again 1 6 you are going to get 7. So it is not possible. Next 1 3. Yes. 1 3. If you are going to add 1 3 you will get 4. So it is even. Again 1 5. 5 plus 1 is 6. So I can take 1 5. Fine. Again take the second element paired with first. 2 2. Yes, it is even. Next 2 4. Yes, it is even. Why? Because 4 plus 2 is 6 is even number. 2 plus 2 is 4 even number. Write down all those possibilities. So 2 plus 6 is even. Again nothing. 3 3 is even. 3 5 is even. 4 2 is even. 4 4 is even. 4 6 is even. If you want, you can cross check this. Apart from these ordered pair, you cannot get any one extra pair, so that when you're going to add, it will become odd number. But what we required is it will be even number. So 3 plus 5 is 8. Again even. 4 plus 2 even. 4 plus 4 even number. 4 plus 6 even number. So we have to list out an ordered pair in such a way that when you're going to add an element within the ordered pair, the element should become even. So I have listed the ordered pair in a relation R. Now we have to discuss the nature of the relation. The better thing is here not mentioned any of the methods, right? It is easy to construct a matrix, so go through the matrix. Fine. In matrix, you just write down the elements 1 2 3 4. First set element you have to write here, as I already told you, and second set element you list down here. Fine. Now keep on writing the relation. We don't have an element 1 2, so 0. Again we don't have an element 1 4, 0. 1 6, 0. 1 3, yes it is, so 1. 1 5, it is there, so it is 1. Next 2 to 2, yes I have. Again 2 to 4, I have. Again 2 6, I have. 2 3, I don't have, so 0. 2 5, it is not there, so 5. 0. 3 2, we don't have element 3 2, so 0. 3 4 is also not there, so 0. 3 6 is also not there, so make it as 0. But 3 3 is there, so it is 1. 3 5 is there, so it is 1. Next 4 2, it is not there, so make it 0. It is here. See 4 2, so make it as 1. Next 4 4 is there, so 1. 4 6 is there, so 1. 4 3 is not there. 4 5 is not there. Now we can easily talk about reflexive, right? So when do we say matrix is reflexive? Only when all the principal diagonal elements should be equal to 1. So here it is not the case, so it is not a reflexive. Fine. Now let me talk about symmetric. So when do we say it is symmetric? All the upper and lower triangular elements should be same. But here it is not the case. See here, all the elements are different. So it is not symmetric as well. Fine. Now talk about antisymmetric. Antisymmetric also format should be same, as I already solved so many problems on this. So here it is not the case. See, below the principal diagonal and above the principal diagonal elements, element format is not equal, so it is not an antisymmetric. Fine. But coming to the concept of transitive, just by looking at the matrix, we cannot decide whether it is transitive or not. So next concept is, how can we find, given a matrix, how can we find transitiveness? the thing is, we have to check the condition mr square is equal to mr. I've already given the notes of the same, right? How can we decide a given matrix is transitive or not? You just go through the notes, you will get mr square plus mr should be equal to mr. In the sense, first write down the matrix of relation as I done now. Again, do the find out the mr square. When you're going to add these two terms, matrices, you should get back the same concept, same matrix. If this condition satisfies, then only we can say it is transitiveness. So otherwise we cannot say whether it is transitive or not. So up to here, you just understand only reflexive, symmetric and antisymmetric. In the next session, I will explain how can we decide whether the matrix is transitive or not. Hope you understand this concept. Let me teach how can we decide, given a matrix of a relation, how can we decide transitiveness. So question is, find the nature of the following relation. Just in one statement you can write given matrix is not reflexive. Why? Because look at the principal diagonal element, it is not 1, so it is not reflexive. So talk about symmetric. So above principal diagonal element, either 1 should be there or 0 should be there, and below principal diagonal element as well. So it is not the case. So this matrix is not reflexive and not symmetric. Now the new concept is coming to the concept of transitivity. So for transitivity, it is important. So given a matrix, we can decide whether it is transitive or not only by checking the condition mr square is equal to, mr square plus mr is equal to mr. In the previous session also, I have told you the same thing. If a matrix of a relation satisfies this particular condition, we can say the given matrix is transitive. So let me verify whether it is transitive or not. So what we have to find is mr square. Why? Because mr is already given in the problem. So how can I find mr square? It is just equivalent of matrix multiplication. Suppose given a matrix A, how can you find A square? Given a matrix A, you can find A square by using A into A, right? Similarly, mr square, I can write that as mr into mr. So matrix of relation, let me write it once again, 1, 1, 1, 0, 0, 0, 1, 1, 1, 0, 1, 0, 0 into 1, 1, 1, 1. The same matrix I have to write again, 0, 1, 0, 0. Now, as usual, matrix multiplication, but the difference is that we have to use join and meet concept. Now, as I already told you, join will be equivalent to addition in usual mathematics. Meet will be equivalent to multiplication in usual maths. Now, matrix multiplication, first row with first column. 1, what I have to write? Join or meet? Meet, right? Or else, instead of writing each and every term, since it is 4 cross 4 matrix, so it will take more time and needs lot of space. So I'll just do directly. 1 meet 1 is 1, right? Next I have to write join. 1 meet 0 is 0. Join. 1 meet 1 is 1. Join. 1 meet 0 is 0. I think it is familiar to you. Why? Because I have already done the same concept in the class. Now, first row with the second column. 1 meet 1, 1. Join. 1 meet 0, 0. Join. 1 meet 1, 1. Join. 1 meet 1, 1. Next, third row. Next, third row. 1 meet 1, 1. Join. 1 meet 0, 0. Join. 1 meet 1, 1. Join. 1 meet 0, 0. Next, 1 meet 1, 1. Join. 0 meet 0, 0. Join. First row only, right? First row with last column. 1 meet 1, 1. Join. 1 meet 0 is 0. Join. 1 meet 1 is 1. Join. 1 meet 0 is 0. Do the same thing for all the rows. So I can directly write, or else let me write, since you have 0 here, so all the elements will be 0. If you're going to multiply any row with any of the column, you will get 0 only. So 0 join, 0 join, 0 join, 0. 0 join 0 join 0. Why? Because I have all the elements as 0. So if you're going to multiply 0 with any of the element, you will get back 0. So that is the reason I have written 0 here. Fine. Next one, third row. Third row I have 1, right? So 1 with this row with first column. 1 meet 1, 1. Join 1 meet 0, 0. Join 1 meet 1, 1. Join 1 meet 0, 0. Clear? Next, same row with the second column. 1 meet 1, 1. Join 1 meet 0, 0. Join 1 meet 1, 1. Join 1 meet 1, 1. Fine. Similarly, write down all the values multiplied first and then join those. 0. Since you have only one element, no? Anyhow, do the same concept. 0, 0, 0, 0, 0. Join 0, join 0. 0 join 0 join 0 join 0. Why? Because see here, I'm going to multiply this with this one. First here I have to do first column, second column, third column, at last fourth column. So 0 meet 1 is 0. 1 meet 0 is 0. 0 meet 1 is 0. Again 0 meet 0 is 0. So the same thing I have done. If you're finding any difficulty, you may free to ask. Now I have a join concept. Add this 1 plus 1, 1. It is not usual addition, it is join and meet concept. Hope you understand this. Why? Because you have already solved a number of problems. 1 join 1, join 1. So 1. Again 1. Again 1. Next, since all the element is 0, I can directly write 0. Again 1. Since I have 1, you can blindly write 1. 1. Next 0. All the elements 0, so you can directly write it as 0. Right? So I have obtained this value. This is what the value of mr square is equal to mr square value, right? mr dot mr value. So mr square matrix is this one. Am I correct? Now I have to do mr square plus mr. So I have to add mr matrix for this matrix. I can directly add this. You just look at here. Addition in the sense it will be equivalent of join. So direct addition we can do 1 plus 1, 1. Join concept. Again 1 plus 1, 1. 1 plus 1, 1. 1 plus 1, 1. Right? mr square with mr matrix I am doing. Again I have zeros. With adding zeros you will get 0 only. Again I have ones. Adding with ones you will get 1 only. Again in the fourth column I have 0 with all the zeros, but except here you have 1. So 0 plus 1 will become 0. Rest of the values will be 0. Hope it is clear, right? I'll just revise once again. Why? Because it just looks like a clumsy. I'm sorry, I cannot do anything. Right now mr square I have to find. Only thing is, in order to verify whether it is transitive or not, I have to verify this condition, right? So to find mr square I have to solve mr into mr. So I have written this matrix with the same matrix, and I have applied join and meet concept. Since it is 4 cross 4 matrix, so I have not written meet for each and every term. I have directly simplified and I have written 4 columns. So I have applied the join concept. I have written mr square here. Now LHS part is mr square plus mr. I am going to simplify LHS part mr square plus mr. When you are going to add, the meaning is you are applying the join concept. So mr square matrix is here. So for this matrix you are adding the original matrix. So first row all the elements is 1. Here all the elements is 1. So when you are going to add 1 plus 1, as per the join concept you will get 1 only. Right? Again zeros we have, so zeros plus 0 will give rise to 0. Again in the third row you have all ones. Here also all ones. So 1 plus 1 you will give all values as 1. So in the last row all the elements is 0, but here you have only 1. So 1 plus 0 will become 1. Rest of the elements is 0. Now you can look at the given problem. This matrix I can write as mr. Right? Therefore it satisfies the condition mr square plus mr is equal to mr. So if this is the case, the given matrix is transitive. given matrix is transitive. So if the given matrix satisfies this condition, mr square plus mr is equal to mr, then the given matrix is transitive. The key point is while finding the mr square, you have to multiply mr with the same matrix, and you have to do it in join and meet concept, not usual multiplication. Remember. Fine. Hope it is clear. Now, yesterday's class I have given one problem. There I have not decided whether it was transitive or not. You just go through the problem and let me know whether it is transitive or not. Follow the same procedure, and everyone should put the solution of that problem in the group. Hope you will do it.